guys, we're going to talk about geometric sequences. And a geometric sequence is a sequence of numbers in which the ratio remains constant. So what does that mean? That means the number that you multiply to get to the next term remains constant or the same each time. All right, so how can you find this common ratio? You can find this by dividing each term by its previous term. Okay, so if you remember, multiplication and division are inverses of each other. So you can look at this kind of as multiplying or dividing, and we're going to look at it kind of in both ways. So look at number 1, identify geometric sequence. Determine whether the following represents a geometric sequence. If yes, identify the common ratio. All right, so the first way you can look at it is say 2 times what gives me 10? Well, if you know your multiplication pretty well, you know that 2 times 5 gives you 10. And then you can say 10 times what gives me 50. So here I can say, okay, I'm going to multiply by 5. I'm going to multiply by 5. And I'm going to multiply by 5. Okay, so because that number stays constant, then that means yes, this is a geometric sequence. So yes, this is a geometric sequence. And our ratio equals 5. Now, if you look up here above, it says you find it by dividing by the previous term. All right, so if you're not great at your multiplication tables, you can say 250 divided by 50 equals what? And all you have to do is plug this in your calculator. So 250 divided by 50 is 5. 50 divided by 10 is 5. And 10 divided by 5 is 2. So you're going to find that common ratio by dividing as well. Okay, I kind of think of it as multiplying, but not everyone is great at multiplying. All right, so let's look at this by dividing by the previous term here. All right, so if we do 5 divided by 15, that's going to be 1/3, or we do 15 divided by 45, that's 1/3 as well. And 45 divided by 135, that is 1/3 as well. So yes, this is a geometric sequence, and our common ratio this time is 1/3. All right, now for the next one, it's got 6, 18, 24, and 30. So let's do 30 divided by 24. 30 divided by 24 gives me 1.25. 24 divided by 18 is 1.33. We can already see that those are different. And then 18 divided by 6 is 3. So because those are different, this is not a geometric sequence. So just when it says determine whether the following represents a geometric sequence, if it's not, there's no common ratio. So you just put a no. All right, for the next one, you've got negative 56 divided by 28. So that's going to be negative 2. And then 28 divided by negative 14, and that's negative 2. And then 14 divided by 7 is negative 2. So this is a geometric sequence with a common ratio of negative 2. All right, I've moved it up a little bit so that we can see the next 2 examples. So if you look at example 5, we're going to say negative 10 divided by 20 is negative 1/2. 20 divided by negative 40 is negative 1/2, and negative 40 divided by 80 is negative 1/2. So this one is geometric, and the common ratio is negative 1/2. All right, number 6. Probably want to use your calculator for this one. Negative 576 divided by negative 144. 2 negatives is going to make that a positive 4. Negative 144 divided by negative 36 is positive 4. Negative 36 divided by negative 9 is positive 4. So again, this one is yes, and your ratio is 4. All right, on the next part, it says continuing geometric sequence. Given the geometric sequence, find the next 3 terms. So basically what you're doing is that you're looking for the pattern, and it's saying given it's a geometric sequence. So when it says it's given, that means you know that it has a common ratio. So all you have to do is find the next 3 terms. So if you look at the first 2 terms and you say negative 21 divided by 7, that's a negative 3. So you know to get to the next term, again, multiplication and division are inverses of each other. So to get to the next term, you're going to have to multiply by a negative 3. So negative 3 times 63, which is the term here that you see. So this term here times negative 3, and that's going to give you negative 189. So your next term is negative 189. And once you find that common ratio, you just have to keep multiplying. So times that number by negative 3 again, and that's going to give you 567. And then multiply that by negative 3 again, and that gives you negative 1,701. All right, so what is the common ratio for number 8? So let's do 768 divided by 3,072, and that's going to give you 0.25, which is the same as 1/4. Okay, so what is 192 times 0.25? And that's going to be That's going to be 48. All right, 48 times 0.25 is 12. So you're just dividing that by 4 basically. Multiplying by 1/4 is the same as dividing by 4. So 12 times 1/4 is 3. All right, so number 9. 4 divided by 8 is 1/2. So we're going to look at that and say, what is half of 2? Half of 2 is 1. What's half of 1? 1/2. And what's half of 1/2 is 1/4. All right, number 10. Negative 25 divided by negative 5. So that would be a positive 25. Positive 5. And I'm going to do negative 125 times 5 to get my next term, and that's going to be negative 625. So again, the reason I'm only doing one number to find out what my common ratio is, again, it says it's given that it's a geometric sequence. So if we know it's a geometric sequence, we know it has a common ratio. So all we have to do is look at 2 of the terms to find the common ratio and then go from there. All right, the next term, if I multiply that by 5, I'm going to get negative 3,125. And if I multiply that by 5, I'm going to get negative 15,625. All right, for the next thing we're going to look at the geometric sequence formula. Okay, so this is the general formula. The nth term of a geometric sequence can be found using the following formula. And sometimes you'll see different versions of this, but this is kind of the general version that we use. So a subscript 1, okay, a subscript 1 is the first term. R is your common ratio. So a to the nth can be found by taking your first term times your common ratio raised to the n minus 1 power. All right, so let's look at a couple examples here. So if we do 9 divided by 3 is 3, 27 divided by 9 is 3, so we can say our common ratio is 3. All right, so we want to find the 7th term. Okay, so we know that we can write this as a to the n term equals our first term, which in this case is 3, times our common ratio raised to the n minus 1 power. And if we want to do that for the 7th term, instead of writing a to the n, we just write a to the 7th because that's the term we're looking for. We're still going to use the first term times our common ratio raised to the n. N in this case is 7 minus 1. Okay, so we are going to solve these, but right now it just wants you to write a rule, which means write an equation. Okay. All right, so this one we're going to look at 20 divided by -4. That would be -5. -100 divided by 20, -5. So our common ratio is -5. So let's look at a to the 7th term again. A to the 7th term, we're going to use our first term times our common ratio, which is -5. It's negative, make sure you put that in parentheses. And then our 7th term would be to the 7 minus 1, or to the 6th power. All right, if you did work that out, we would do exponents and powers first. So we'd have -4 times -5 to the 6th power. And again, you do this to a power first and then multiply by -4. You would get 62,500. All right, so if it asks you to write a rule, oh, it does say then find this. Let's go back and solve this one too. All right, so we have 3 times 3 to the 6th power. And then you do 3 to the 6th power in your calculator. Just do 3 raised to the 6th power and then times 3. And that's 2,187. All right, moving on to number 13, we're going to look at 100 divided by 200. So that would be a ratio of 1/2. 200 divided by 400, 1/2. So we know R equals 1/2. All right, using the same directions as above, we're going to look for the 7th term. So we're going to do a to the 7th equals our first term times our common ratio raised to the n minus 1, and then find the 7th term would be 400 times 1/2 to the 6th. Again, you always do parentheses to exponents first and then multiply. So do 1/2 raised to the 6th power times 400, and you're going to get 6.25. So that means if you continue this sequence, your 7th term would be 6.25. All right, we will finish this up in the next video.